All right, section 2.4. We are talking about sketching graphs of functions here. Before we get too far, I want to go through some of these keywords here, kind of explain what they are. I know I have the definitions there, but some of these are terms you're familiar with, and some of them might be sort of newish, okay? So x-intercept, that is where a graph crosses the x-intercept, crosses the x-axis. The y-intercept is the y-coordinate where the point where the graph crosses the y-axis. I'll try and talk good here. Positive. When a function is positive, that's the part of the graph that lies above the x-axis. Okay, so positive means that we're talking about y values being positive, so that would be above the x-axis. All right. Negative is when the function is below the x-axis. Okay, so obviously below the x-axis would be when the function is negative. When it's increasing, that's when it's going up from left to right. That's when we talk about increasing. The y values are going up as you move from left to right across the graph. When it's decreasing, I'm going down from left to right. Okay, we talked about this in another video, I think, so that would be decreasing. And the end behavior we've talked about already. That is when what is happening at the ends of the graph. As x moves to the right and as x moves to the left, what is happening to the y values. Okay, so what we're going to try and do is take a bunch of information about this, what would you say, a bunch of features of the graph, and we are going to try and sketch a graph from that. Okay, so let's start with this one here. We have number one. So let's see, we want the y-intercept is -70. What I like to do is if I'm given a specific point, I like to just get that down on the graph. So -70, y-intercept right here. Okay. And then we need the function to be positive when x is less than -30. Oh, and also, by the way, it's linear. Okay, so we know we're going to be drawing a line. We want it to be positive when x is less than -30. So let's put -30 on the graph. This one we can kind of pick for ourselves. There's no scale given to us. Excuse me. So the function is positive. That means it's got to be above the x-axis over here. Okay. The function is decreasing for all values of x. Well, look, this has got to be a line. And so if it's going to be positive or above the x-axis over here, the line's got to do something like this. And it's decreasing. It says decreasing for all values of x. That means that the graph is always falling as you move from left to right. And here, this is always decreasing. This line is. Okay, by the way, this is -70. I should write that. All right, and then last thing it says, check the end behavior. As x approaches positive infinity, y, or f of x, approaches negative infinity. That does happen. See, this is going down as you move to the right on the graph. And as x approaches negative infinity, f of x is approaching positive infinity. That means that as you move to the left, the y values are going up. So that does happen as well. Okay, so that is a sketch of number one. Let's go on to number two now. Number two, use the given features to sketch a nonlinear graph. All right, well, now we've got an actual grid here, so we're going to be a little bit more careful than just plopping the points on the xy plane. The y-intercept is -5, so let's draw that in. The function is positive for -3, or for x less than -3 and x greater than 4. So let's put -3 on here. Let's put +4 on here. All right, now we have a minimum at 2, -6. So that's a low point at 2, -6. So that's right here. All right, and then we have the function increasing when x is greater than 2. So that means from this minimum, it has to go up like this. And this also checks out that it would be above, or it's positive right here, positive. And over here it has to be negative. Oh, sorry, over here it has to be positive also. Based on this one right here, right? The function is positive in those two spots. So minimum, positive here, positive here. And so this thing must connect right here. Last thing we can do is check the end behavior. As x approaches infinity, f of x approaches positive infinity. Let's check. As we move to the right here on the graph, where did the y values go? Well, they're going up. So they are going to positive infinity. What about the x values? As you move, the y values as you move to the left to negative infinity. Well, they are also going up. Okay, so yes, as x approaches negative infinity, y's, or f of x, approaches positive infinity. So there's a sketch of that one. By the way, I didn't say this at the beginning. It did say nonlinear. Okay, it would have been possible to draw a line like that fit these characteristics, but we didn't need to. It said nonlinear at the beginning. I just forgot to highlight it. Okay, last one here. Number 3. Jose decides to test to drive a car. He drives the car for a little over 5 minutes. We're going to sketch the graph of his speed versus time. Okay, so we almost always put time on the x-axis, and we'll put speed on the y. Okay, and it looks like a maximum speed of 160. So when we pick our scale here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 tick marks. So if we go 20 per line, that would put 160 right here. Okay. Now this isn't written on your paper, but it's just a typo, I forgot to type it. But he reaches that speed, the max speed, after 30 seconds. Okay. So that's a critical piece of information. All right, so let's try to start sketching this. If Jose starts driving at 0 miles per hour, so starts driving means at time 0, it's 0 miles per hour. Oh, actually, 1 second. We have 5 minutes is the length of time. So let's check the x-axis scale. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we take that one, I think we'll need an extra tick mark over here. I should have put a bigger graph in. I didn't. I'm sorry. But let's go. If we have 11 tick marks, then let's go 1 minute every 2. So 1, 2, 3, 4. This will be 5 right here, and then 5 minutes and 30 seconds right here. Okay. All right. So start at 0, 0. Reaches his maximum speed at 160 miles per hour after 30 seconds, and increases his speed constantly. That means that there's a line for 30 seconds up to 160. Okay. So at 30 seconds, that's 0.5 minutes. Right there. Okay, and then let's see, Jose's speed increases. Yep, and then at the 2 minute mark, so we have to assume that he just stays going 160. Then he says at the 2 minute mark, he starts decreasing his speed for 30 seconds and then goes down to 100 miles per hour. So then he decreases for 30 seconds to 100 miles an hour. So this is 20, 40, 60, 80, 100 right here. Excuse me. So, whoops, right there, 100. Goes down like this. All right, and then it says he stays going 100 miles per hour for 2.5 more minutes. So he's at 2.5 right now. He's going to keep going until he hits 5. And then it says at the 5 minute mark, he suddenly decreases his speed for 30 seconds until he stops. So then he drops down here to 30 seconds, or 5 minutes and 30 seconds. Okay. So again, I didn't give you a fantastic graph there, but that's how you sketch graphs based on the characteristics of the graph that you're given. Not everyone's answer will be the same, but right answers will have the same property, right? So it's like for number 2, you would never have a correct answer that was a parabola that was like upside down, right? That would never happen. So there's many right answers, but there are certainly obviously ways that you can get it wrong. So how do you do this in general? Plot points that you know, or that are given. Intercepts, minimums, maximums, things like that. Okay? And then try to look at positive and negative. When is the graph below or above the x-axis? And then then I would look at increasing and decreasing. And then finally, check your end behavior, because you should have a pretty good sketch at that point. But if you don't, use your end behavior to figure out what the graph has to look like. And that's pretty much it for section 4.